So in this video, I'm going to go over how to find derivatives in a much more algebraic sense. Instead of finding the derivative at a specific point, I'm going to define the derivative as a function of x. I'm going to actually be able to find the derivative of every point in that function. So very specifically, I want to go ahead and start off by talking about the limit of the difference quotient for the derivative formula here. So I'm going to define the derivative as f prime of x. This is just another way to write the derivative instead of writing it as dy dx. Okay, so this is again just another way to say it, because sometimes we have multiple functions, and so we would write f or g or h with a little apostrophe, called it prime, prime, f prime of x. And I'm going to define this again as a limit and I'm going to use in this case the symbols that your textbook uses, which is delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Now, Mr. Harold personally doesn't use delta x. Instead, Mr. Harold uses the letter h. You know, it's your choice. You can choose whichever way you want to do it. I'm just a personal big fan of the of h, h for Harold. So we're going to do f of x plus h minus f of x, all divided by h. Okay. Now I'm going to go ahead and mention to you while I'm sitting here thinking about it that this fraction is called the difference quotient. Okay, notice it's called the difference because it subtracts, and quotient because it divides. It's called the difference quotient. So this is actually a multi-step process. So the first step in doing this, and I'm going to kind of write these as I do the first example. Step one is to actually plug in x plus h into the function. Okay, so what I mean by that is in this first equation, or this first function, I've got 3x plus 2. So I'm going to plug in x plus h as x and just kind of simplify that and see what happens. Okay, so 3 times x is 3x plus 3 times h makes 3h plus 2. Now that I've got that handled, I'm going to move on to step 2, which is subtracting the original function from it. Okay, so if I have this simplified form, 3x plus 3h minus 2, excuse me, plus 2, 3x plus 3h plus 2, I'm going to subtract that pink thing, the minus 3x minus 2, and we'll see what happens. So 3x minus 3x cancels, 2 minus 2 cancels, and I'm left over with just 3h. And that leads me into step 3, which is, in this case, dividing by h. Okay. So if I take 3h and I divide by h, I get the answer 3. Now, normally, most problems do have a step 4, which is finding the limit as h goes to 0. Okay? But in this case, I have no more h's left over, so my final answer should just be 3. Now, based off of this information, I want you to think abstractly for just 1 second. If I go back up and I look at this original function, 3x plus 2, that is a straight line. Its slope, because this is in slope-intercept form, is 3. So something to think about here is that its slope, because it's a straight line, is the same number everywhere, and it's always 3. Now that's what makes lines so very special. But the question is, what happens if I try a different function, like for example, example 2, where I've got x cubed minus 12x. In this case, that is no longer a line, so its slope changes depending on what x is. So let me go, excuse me, a little bit further, and I'm going to do the same process, the same steps. I'm not going to write them all down. I'm going to write the same steps, though, in doing this work. So first and foremost, I want to plug x plus h in to this function. So let me write this down. I'm going to plug in x plus h for x. Now, every time I see an x, I'm going to do it. So x cubed, I'm going to turn that into x plus h cubed, minus 12x, I'm going to turn that into x plus h. Now, this involves foiling out. Big mistake that I always see people make is they take x plus h cubed and they write it as x cubed plus h cubed, which that is just plain wrong. So do not do it. Don't do it. You need to actually multiply x plus h times x plus h times x plus h. You're going to have to do it 3 times because it's cubed. So I'm going to go ahead and do the first one. So x times x makes x squared. We're going to do x times h, which makes xh. We're going to do h times x, which, again, order is not going to be particularly important. And then we're going to do h times h, which makes h squared. I'm going to go ahead and simplify that just a tiny bit because I've got 2xh's. So I'm going to write that x squared plus 2xh's plus h squared. And now I'm going to try to multiply that again by x plus h. So we're going to do x times x, which makes x cubed. And I'm going to go ahead and write all this up here. In the next step, we're going to do x squared times h, and that's going to give me x squared h, but I'm going to have 2 more of those because 2xh times x makes 2 more. So that's going to be 3x squared h. Then we'll do, I've done the 2xh times x. I'm going to do 2xh times h, which is going to give me 2xh squared. But again, I'm not going to write that down yet because I'm going to have another one. X times h squared gives me another. So I'm going to have 3xh squareds. And the last one, I'm going to do h squared times h, which is going to give me h cubed. Okay, so hopefully you guys ran through all those steps. Again, please just double check it to make sure you're right. I've still got to do this minus 12 times x times h, so make sure you distribute that negative, negative 12x minus 12h. Okay, that h does not look very pretty. All right, let me write that pretty. Okay, there we go. So step 1, plug in x plus h into the function. I did it. That was step 1. Got it. All right, step 2, subtract the original function. Here's my original function. So if I subtract x cubed and I subtract negative 12x, so I'm actually going to add 12x in here, those things should cancel. Okay, that's going to leave me with 3x squared h plus 3xh squared plus h cubed minus 12h. Next step, that was step 2. Step 3, divide everything by h. So divided by h, divided by h, divided by h, divided by h. Let's see what happens. 3x squared h divided by h leaves me with 3x squared. 3xh squared divided by h makes plus 3x, still has one h left over. H cubed divided by h still has h squared. Minus 12h divided by h makes minus 12. Last step, take the limit as h goes to 0 of that thing, 3x squared plus 3xh plus h squared minus 12. What that means is anything with an h in it turns into 0. So this is going to be 3x times 0. H squared, 0. So I'm going to be left over with a final answer of 3x squared minus 12. And that is my derivative. So I write f prime of x equals 3x squared minus 12. Notice, this does depend on whatever the x value is, which is what I said originally. The function x cubed minus 12x does not have a consistent slope. It's not the same slope everywhere. So its value, the slope, depends on whatever x is. Now, I'm going to do 2 more examples. We've got example 3 and example 4. Notice, example 3 is a radical. It's a square root function. I'm still going to follow the same process. First and foremost, I need to take f of x plus h. I need to plug in x plus h into that function. So x plus h minus 4. Now, I'm going to try to subtract the original function, which is the square root of x minus 4. There's one problem. These are 2 separate square roots. There is no combining that you can do. This is very different than the last 2 problems because I could simplify those things, but I can't on this one. So notice in this case, there's really nothing I can do here with this. So what I'm going to try to do is I'm going to try to divide by h, which is going to be my next step. Now that kind of puts me in a pickle because, again, I can't really take out an h from anything. I can't take it out of this square root because it's not really applicable. That h is in the numerator is under a square root, but the h in the denominator isn't. So I can't really do that. And so when I go to try to find the limit as x, or excuse me, as h, not as x, but as h goes to 0, I'm going to get one of those indeterminate forms. And that's where our algebraic methods step in. We kind of need to approach this process a little bit differently. So I'm going to try to multiply this thing by its conjugate, which is the square root of x plus h minus 4 plus the square root of x minus 4. And if I do it to the top, I got to do it to the bottom. So x plus h minus 4 plus the square root of x minus 4. All right, let's see what happens here. So in the denominator, let me write that down, limit as h approaches 0. I'm going to leave that separated out. So it's h times the square root of x plus h minus 4 plus the square root of x minus 4. In the numerator, we've got the square root of x plus h minus 4 times the square root of x plus h minus 4. So that square roots are going to get rid of each other. We're going to be left over with x plus h minus 4. Then I'm going to have a positive square root of x plus h minus 4 times a positive square root of x minus 4. But that's going to cancel with this negative square root of x minus 4 times a positive square root of x plus h minus 4. And then we'll do the last one, a negative square root of x minus 4 times a positive square root of x minus 4, which leaves me with minus x minus 4. Please make sure to use parentheses so you remember to distribute that negative there, which I'll go ahead and do right now, just so I don't forget. So we're going to have x plus h minus 4 minus x plus 4 divided by h, parentheses, x plus h minus 4 under one big square root plus the square root of x minus 4 there. Now, watch what happens when I start looking at canceling things. X minus x, negative 4 plus 4 leaves me with an h on top. Then I've still got this h on bottom. And the square root of x plus h minus 4 plus the square root of x minus 4. These h's will cancel. I'm left over with a 1 in the numerator. 1 over the square root of x plus h minus 4 plus the square root of x minus 4. Now, I can plug in 0 for h. What's going to happen there? I'll show you. 1 over the square root of x plus 0 minus 4. It's almost like that 0 doesn't even need to be in there. It's just going to be x minus 4. But then I've got two of them. I've got one square root of x minus 4 plus another one. So I'm going to rewrite that as my final answer. It's 1 over 2 times the square root of x minus 4. And that, my friends, is the final answer. That is my derivative, f prime of x. The final answer again, and I'll write it nice and pretty so you guys can see it clearly. All right, again, it's 1 over 2 times the square root of x minus 4. Okay, there we go. Want to make sure it looked nice. All right, I'm going to do one more. F of x equals 1 over x plus 1. Again, I need to plug in x plus h first. So 1 over x plus h plus 1. I'm going to subtract the original function, which is 1 over x plus 1. Notice there wasn't any simplifying I could do to the original, and now there's nothing I can do to subtract those two things together because they don't have a common denominator. But wait, we can make a common denominator, and that's probably what I'm going to do before I actually divide everything by h. I'm going to have to divide everything by h eventually, but I don't have to do it right now. So again, just focus on the numerator first. Make a common denominator. So this first fraction needs an x plus 1. So I'm going to write x plus 1 in its numerator times 1 minus 1, so there's that minus 1, times that denominator, which is x plus h plus 1, all over, I'm going to multiply those two denominators together, x plus h plus 1 times x plus 1. All right. Again, this is still all over h, but I don't really want to worry about that all over h yet. I'm going to go ahead and still keep simplifying that stuff. So I'm going to write this down. So we've got 1 times x plus 1, which is just going to be x plus 1. And I'm going to distribute this negative 1. So make sure all these turn negative. So we've got minus x minus h minus 1 all over x plus h plus 1 times x plus 1 all over h. So we're going to start canceling x minus x, positive 1, negative 1. So I've got a negative h over x plus h plus 1 times x plus 1 all divided by h. Now, at this moment, I'm going to start thinking about multiplying by that reciprocal. Well, in this case, I'm going to multiply by the reciprocal of the h. The reciprocal of h is 1 over h. So I'm going to have a negative h over x plus h plus 1 times x plus 1 times 1 over h. These h's will cancel, but we'll still have a negative 1 on top. And then I need to remember to go back and do my limit as h goes to 0 of negative 1 over x plus h plus 1 times x plus 1. Now again, I can plug in 0 at this moment, so let me go ahead and do that. Negative 1 over x plus 0 plus 1 times x plus 1. At x plus 0 plus 1, pretend like that 0 is not even there. You're going to have negative 1 over x plus 1 times x plus 1. You could multiply that out if you want to, but Mr. Harold would honestly just prefer if he wrote negative 1 over x plus 1 squared. And that, again, friends, is the final answer. That is my f prime of x. That is my derivative. Negative 1 over x plus 1 squared. Again, you could multiply that x plus 1 squared out. You would get, and I'll write it down, negative 1 over x squared plus 2x plus 1. But let's be honest, the first way I wrote it was a little bit prettier. So now that I've got that covered, hopefully this helps you guys see just how important finding limits are algebraically, because they come back again. Now, I'll see y'all